Repetition. In order to program a repetition or looping construct, you must include 4 different parts for it to work properly. Before you get into the loop, you have to initialize your looping variable to its starting value. The other 3 parts form the loop itself: a test of the looping variable, execution of the instructions inside the block, and finally, a modification of the looping value. If any of these 4 elements are missing, your loop may not work the way you expect. There are many times when you want to check to see if a certain condition has been met before you start a loop. If this is the case, then you'll want to use a while loop. Operation of the loop is pretty straightforward. First, you test to see if your looping variable meets a certain condition. If that condition is met, then you do a specific set of operations. Normally, the last thing you do in this block is to modify the looping variable. Finally, you go back and check the variable again. When the test condition is not met, the loop terminates. Because the test is done first, there's a possibility that the operations in this block never get done. If we look at it graphically, the first part of a while block is to test the looping variable. If it's true, program execution continues on through the normal sequence of instructions. This includes modifying the looping variable. It goes back, tests the condition again, and when the condition is no longer true, the loop terminates and we move on to the rest of the program. To write well-structured code, it's important to think of the repetition construct as a block. This means there should only be one way to get into the block and one way to get out. The structure of a while block has 4 main parts: the initialization, the test, the loop operations, and the modification. We've seen a flowchart showing the structure, but let's also look at it in pseudocode. The first part is the initialization. Here we use the keyword initialize to set up the looping variable. Next comes the test. Here we use the keyword while to start the repetition construct and to indicate that we're going to test a condition. The third section, shown here in pink, contains the operations that will be performed if the given condition tests true. Somewhere in this block there must be an instruction to modify the looping variable. Once these operations are complete, the program sequence returns to the while statement again. Here we can see an end while keyword to indicate the end of the loop. Whenever the test condition is no longer met, the loop is terminated and execution continues on at the instruction after the end while. If we're writing pseudocode for assembler, we need to add a little bit more detail. First, we'll initialize the looping variable. Before we test, we must ensure that the first of our values is in one of the registers. This operation is shown in brackets here because sometimes the value is already in a register. If it is, then there's no need to include this instruction. The test itself requires 2 steps. First, a comparison of the 2 values that sets the appropriate bits in the status register, and then a branch operation that makes a decision whether to branch or not based on these flags. Notice that this instruction branches to the instruction after the loop if the test is not true. This reverse logic allows us to write our assembler instructions with the repeat block in its logical sequence. The block of looping instructions includes one to modify the looping variable. Its last instruction is a branch that takes the flow back to the test instruction. There are many times when you want the loop to execute at least once before you test for the terminating condition. If this is the case, then you should use a repeat until loop. Operation of the loop is fairly straightforward. First, the operations are executed, including the modification of the looping variable. Then the looping variable is tested to see if it meets a certain condition. If the condition is met, the loop is terminated. If the condition is not met, it goes back and repeats the loop again. Because the test is done last, the operations in this block will always get done at least one time. If we look at it graphically, the first part of a repeat until block is the execution of the loop operations. This includes modifying the looping variable. The variable gets tested, and if it doesn't meet the certain condition, it goes back and repeats the operations. If the conditions are met, the loop is terminated. To write well-structured code, it's important to think of the repetition construct as a block. That means there should only be one way in and one way out. The structure of a repeat block has four main parts: the initialization, loop operations, modification, and test. We've seen a flowchart showing the structure, but let's also look at it in pseudocode. The first part is the initialization. Here we use the keyword initialization to set up the variable. Next comes the keyword repeat, which marks the beginning of the loop. The next section, shown in pink, contains the operations that will be performed until the given condition tests true. Somewhere in this block there must be an instruction to modify the looping variable. Here it's shown in blue. Next comes the test. Here we use the keyword until to indicate that we're waiting for a certain condition to occur. When the test condition is met, the loop is terminated and execution continues on to the next instruction. If we're writing pseudocode for assembler, we need to add a bit more detail. First, we'll initialize the looping variable. Next comes the block of looping instructions, including the one to modify the looping variable. Before we do the test, we must ensure that the first of our values is in one of the register. This operation is shown in brackets here because sometimes the value is already there. If it is, then there's no need to include this instruction. This is followed by the actual test, which has two parts. First, a comparison of the two values that sets the appropriate bits in the status register, and then a branch operation that makes a decision whether to branch back or not based on these status flags. Notice that this instruction branches to the beginning of the looped instructions if the test condition is not met. It keeps looping until the condition is met. At that point, it continues on to the next instruction. There are many times when you want to do a particular task a certain number of times. If this is the case, then you want to use a for loop. In high-level languages, it's normally a variation of a while loop, while in assembler, it's normally a variation of a repeat until loop. In either case, the main difference is that the looping variable is a count, with the loop always executing count times. Because this video series focuses on assembler, we'll consider the for loop to be a variation of a repeat until. Before getting into the loop, the count must be initialized. Then the operations in the loop are executed, including modification of the counter. The counter is tested to see if it's at the specific limit. If it's not, it goes back and does the loop again. If it is, the loop terminates. The structure of a for block has four main parts: the initialization, the test, the loop operations, and the modification. We've seen a flowchart. Now let's look at the pseudocode. First, we initialize the counter. Next comes the block of looping instructions, including the one to modify the counter. Before we do the test, we must ensure that this count is in one of the registers. The operation is shown in brackets here because sometimes that value is already in a register. If it is, then there's no need to include this instruction. This is followed by the actual test, which has two parts. First, a comparison of the counter to the specified limit. This operation sets the appropriate bits in the status register. This is followed by a branch operation that makes a decision whether to loop back or not based on these status flags. If the values are equal, program flow continues on to the next instruction. So to recap, there are three main types of repetition constructs: the while loop, which is a pretest, the repeat until loop, which is a post-test, and the for loop, which can be either. Regardless of which you choose, each requires the same four elements to function properly. First, you have to initialize the looping variable. The loop must contain a test to see if the variable has reached a certain condition. There has to be a block of operations that are repeated, and finally, there has to be an instruction that modifies the looping variable. The only thing that varies from loop to loop is when the actual test is performed.